Hi, I'm Hyunho from KAIST. I'm going to present our geometry-guided online 3D video synthesis with multi-view temporal consistency. Aiming to deliver immersive visual experiences, 4D novel view synthesis has recently advanced based on NUF and Gaussian representations. For low-prime method, process all input data at once to deliver immersive experiences. Progressive reconstruction methods have been proposed for efficient real-time streaming. Recently, pop-frame reconstruction methods based on pre-trained network have been proposed to enable real-time 4D novel view synthesis. The quality of novel view synthesis is influenced by both the distribution and the number of cameras. However, the computation time increases linearly with the number of input cameras. In consequence, the online novel view system selects the minimum number of cameras to generate the target viewpoint. However, changing viewpoints lead to changing inputs, which introduces an additional challenge: view inconsistency. In this work, we address the challenges of view and temporal inconsistency in online novel view synthesis. First, we accumulate multi-view and temporal information into a global geometry representation and resolve collisions between different inputs effectively using a blending strategy. This video compares the result of pop-frame Gaussian splatting methods and our approach. In previous method, temporal free-calling arises from changes in parameters and input cameras. In contrast, our method produces temporally consistent results. Given multiple camera RGBD inputs, we first integrate the depth information into a TSDF to generate a view temporally consistent depth in the target view. Next, we forward render the RGB and depth from each input view to the target view. These forward rendered features are fed into our network to compute blending weights and a background image. Finally, we blend the forward rendered inputs using these weights and background. The forward rendering module can be composed in various ways. First, we can use point splatting, where each pixel is treated as a 3D point. We can also utilize 3D Gaussian parameters predicted by the pre-trained network. We combine the advantages of points and Gaussians by using pixel scale Gaussians, enabling forward rendering that preserves detail while minimizing artifacts. In the previous TSDF module, depth maps from multi-views are integrated into a voxel grid in 3D space. This enables us to obtain a view-consistent TSDF depths. However, the resolution of 3D space increases cubically with n. Rather than constructing the full 3D volume, we estimate depth along each pixel's ray from the novel view by projecting it onto the input views. To update information temporally, we reverse the fixed position of each camera to generate a dynamic mask using the temporal difference of color images. Difference maps are used to accumulate depth from each viewpoint, which is then used to create the TSDF depths. Furthermore, we also utilize the novel view depths predicted from the previous frame. By forward rendering the dynamic masks from each viewpoint, the novel view depth integrates only the static regions. Finally, our blending network module takes as input the temporally consistent geometry obtained from the TSDF, along with the view-specific information. Blending module computes how much each viewpoint image contributes to a view and temporal consistent reconstruction. However, artifacts arise in occluded regions of the input views, so the network also predicts a background region to handle occlusions effectively. This video shows that our TSDF depth acquisition produces more temporally stable results compared to other methods. Our geometry-guided blending network successfully addresses floating artifacts and hallucinations. This video demonstrates that our algorithm produces sharper and more consistent results at the boundaries between people and the background, while also achieving faster computation times. In conclusion, we propose a method that handles multi-view temporal consistency in online novel view synthesis by reversing a global geometric representation. Our method generates multi-view temporally consistent depths by integrating multi-view depths over time using a 2D image-based TSDF. Finally, our geometry-guided blending module produces stable, high-quality novel views by blending forward-rendered images guided by the TSDF depths. Thank you for your attention.